So in this video, we will be discussing about the third problem of today's weekly contest, maximum trailing zeros in a cornered path. So we are given a 2D array of size m into n and each contain a positive integer. Now we need to find a cornered path or we need to find a cornered path. A cornered path is defined as a set of adjacent cells with at most one turn. So as you can see here, this is a cornered path because it has only one turn. This is the turning point. But this is not a cornered path because you can see there are two turns. First you move left, you move right, and then you move again down. Similarly, this is not a cornered path. It has two turns. Like either you can go here by turning there, or you can go here. You can't go both. So that's where this is not also not a valid cornered path. So you have to find a cornered path. For each cornered path, you need to find the number of trailing zeros in the product of all the elements in the cornered path, and you have to return the maximum number of trailing zeros among all such paths. So hope the question is clear. Now let's try to, okay, so for just for example, like if this is the grid, and if we select this cornered path, you can see 15 into 20 into 6 into 1 into 10, this will come as 18,000. So it has three trailing zeros. That's where the answer for this question, for this particular case, is 3. Like we can't have more cornered path which has more than three trailing zeros. Now first of all, I would like to point you that the value of each element is 1000, and we have 10 to the power 5 uh, numbers. So 1000 can be multiplied by 10 to the power 5. So let's say in worst case, what could happen is each element is, let's say, 1000, around 1000, and there are total 10 to the power 5 elements, right? So this will be the total product in worst case. So you can see this is very huge. It will not fit in any integer, and even if we try to fit it in a string, the string size is very huge. So that's where uh, we can't find the actual product. Like we can't find the product like this. Instead, we have to first try to think how, like we have to find only the trailing zeros. We don't care about the actual product. We only care about the trailing zeros. So how a zero can be made? A zero, like basically a 10, right? Number of tens, number of multiples of 10 of that particular number. So the factors of 10 are 2 and 5, right? So uh, basically, if you have to find how many 2's are there in the factors and how many 5's are there in the factors, and just take the minimum of those 2's, because 1 2 and 1 5 can combine and make 1 0, one trailing zero. So for example, if let's say there are 3 2's and there are 4 5's, it means the if you factorize, let's say, number x, and you get let's say 3 2's, so 2 into 2 into 2 into 2, and you also get 4 5's, let's say 5 into 5 into 5 into 5. Now, and there are some more digit, but we don't care about other factors. So now here you can see there will be only three trailing zeros, because 2 and 5 needs to be there in 10, right? So this 2 and 5 will combine to form one trailing zero. This 2 and 5 will combine to form another trailing zero, and this 2 and 5 will combine to form another trailing zero. So basically, minimum of number of 2's and number of 5's will give us the number of trailing zeros in a particular product. So hope this point is clear. So what we have to find eventually is, we don't have to find the product, we have to find the number of 2's and number of 5's in the factor of that product. So if this point is not clear, please rewind the last 1 minute and watch that. It is very important observation for this question, because we can't actually calculate the product, because the product will be very huge. So that's not possible. So that's where we have to find it in a brave manner. And the trick we used here is 10 is made up of 2 and 5, and we are calculating how many 2's are there, how many 5's are there, and then taking the minimum of those two numbers with to give us the number of trailing zeros, because we know 1 2 should combine with exactly 1 5 to give us a trailing zero. So that's where minimum of those two numbers will give us how many trailing zeros are there in the particular product. So if that point is clear, now let's so what we have to find is, basically we have to find the number of fives and number of twos in any product. So let's say you are multiplying x with y. Okay, so if you are multiplying x with y, let's say x has uh, maybe x5 as number of fives and x2s as number of twos. Similarly, let's say y has y5 as number of fives and y2s as number of twos. So by y5 I mean, if we factorize y, we will get y5 number of fives, and similarly if we factorize y, we will get y2 number of twos in the factors. So once we have these two, now in the product how many fives and twos will be there? Number of fives will be x5 plus y5, right? Because we are multiplying it. So let's say there are two fives here and two fives here, so there will be total four fives. So this will, number of fives will be just added up, and similarly number of twos will be x2 plus y2, right? So basically if we are multiplying two things, we are adding their fives, their factor of fives, and adding their factor of twos. So basically when we are saying that, we are, let's say this is a cornered path that we have chosen. So when we are saying that we have chosen a cornered path like this, instead of taking the product of everything and then finding the factors, is not possible, because we have already seen that we can't find the product. So how can we find the factor? That's where we are saying now is, multiplying, let's say multiplying this with this will give us something, and if we know the number of fives here and number of fives here, we will know number of fives in the product of these two. Similarly, let's say we know number of fives here as well, so in the product of these three we will get number of fives as sum of these three fives, right? And similarly if we want to find the number of fives in these three numbers, the sum of fives in these three numbers will give us the actual number of fives in the product. Similar, the same goes for 2 as well. So now first we have found out, like, we are not finding the product, and we will be utilizing the fact that 10 is made up of 1 5 and 1 2 exactly. And then we are saying that, we if we can't find product, how can we find the factors? So for that, what we are saying is, instead of finding the actual product and then finding the factor, let's not find the product itself. We will find the number of fives in each one of them, and instead of multiplying and then finding the number of fives and twos, we will just add these fives and add these twos to get actual number of fives and twos in the product. So if we have to find the number of fives in this particular cornered path, we will just add number of fives in each of these elements. Similarly, we will, if we want to find the number of twos, we will just add twos in each of these elements. By twos or by fives, I mean, how many, if we factorize only this element, how many fives will be there and how many twos will be there. Okay, so hope this point is clear. Now that's the first point. So from that we know that we can find the number of trailing zeros in any coordinate path with just a few additions. So now we have to find the number of coordinate path, right? And the coordinate path is L shaped or reverse L shaped, something like this, right? So these are the possible coordinate paths, or it can be this as well. So basically all possible things that we can form from L will be there. So like these are the possible coordinate paths. Now if you try to find each of these coordinate paths, it will be very tedious, and there will be lot of coordinate paths. So for example, let's just fix uh, this particular length. Like we know that the uh, first half will be this, then the second half can be this, or can be this, or can be this, or it can be this, or it can be this, or it can be this, it can be this, it can be this, and it can be this. So for each of this straight line, we have total, let's say there are total C columns. So number of columns, let's say, are C. So for each line, we will have C coordinate paths. Okay. And how many lines will be there? So number of lines will be one this, another this, another this, another this, and another one this, right? And then uh, so number of lines will be C into R. So this will, like this, these many number of coordinate paths will be there for a particular row, for a particular row, yes, for a particular column, sorry, for a particular column, this many number of coordinate paths are there. Now we have total C columns with us. So number of coordinate paths for each of them will be multiplied with C. So you can already see it is going out of bounds. So we already have given that m and n are 10 to the power 5 and m cross n is 10 to the power 5. So if we just multiply another factor here, it will already go out of bound. So finding all possible coordinate path is not possible, is not the case, because if we try to find all possible coordinate path, we will not be able to solve the problem. So now we have to cut down some of the paths. How will you cut down some of the paths? So for that, let's make another observation. So let's say uh, you take again, you take this path, you take this length. For now, what will be like, do you think it makes sense to take this, or do you think it makes to sense this entire thing? We have to maximize the product, right? So how, like number of the number of fives we get from this and this, and number of twos we get from this and this, will contribute to the answer, right? So why would you stop here? You can go there, you can go till the last, because going till the last will anyway benefit you, right? So what I'm saying is, in for every vertical case, let's not stop in between. Either go till the very end in the right side, or either go till the very end in the left side, because if you stop anywhere here or here or here, it will not give you like the result you will get by coming here will anyway be better than any of these results, right? It may happen that you might not get any extra 5 or 2, but the point here is the value that you will get with starting from here or here or here will be like this. The value will get from here, instead of ending this here in any of these cells, will be greater than any of these cells, or equal. So that's the second observation. The first observation what we made is how to calculate the number of trailing zeros. Second observation that what we are making is, it doesn't make sense to actually stop anywhere in between. We will go either to the very left, or we will go either to the very right. So that goes for the horizontal path. Now for the vertical as well, it doesn't make any sense to so let's say you are stopping here. Okay, so it doesn't make sense to stop here, because you can always stop here and get exact, like either more than what you have been getting here. So basically what we are saying here is, for each cell we have now only four possibilities. Either you go there or here, that's the one possibility. Second possibility is you go there and then here. Third possibility is you go here and then here. And fourth possibility is this and this. So these are the only four possibilities for a particular cell. And total number of cells that we have is R cross C. And we have only four possibility for each cell. So that brings down the complexity to R cross C cross 4. So hope you get the idea what we are trying to do here. If you don't understand what we're trying to do, you can continue watching. We will go through a complete example of this, and it will make things more clear. Otherwise, you can always rewind the past 5 minutes of the video and watch that. So let's continue. So what we have said, is, for let's say we are at this path. This is the current cell that we are at, and for each cell what we will do is, we have only four possibility. Either this, So just calculate the sum of fives in these all cells and calculate the sum of fives in these all cells, and similarly calculate the sum of twos and sum of twos here. Sum them up, you will get the total sum, total twos and total fives in this entire path, and just take the minimum of 2 and 5 and you will get the answer. Okay, so this is what we are doing for every combination. So this is the first combination. Second combination, as we have discussed, is this, and third combination, as we have discussed, is this, and similarly the fourth combination is this. So for each combination we are trying to find the sum of fives and sum of twos in that particular path, and uh, summing them up will give us the total number of zeros, trailing zeros in the final product. So let's look at an example. So let's say this is the given matrix to us, given grid. Now what we are saying is we are only concerned about twos and fives, right? So what we have done here is we have converted this matrix into two matrix, one where each element denotes how many twos are there in the corresponding element, and second grid denotes how many fives are there in the corresponding element. For example, for in 23 there is no 2. If you factorize 23, you will not get 2 and neither get 5. So that's where this and this are 0. Similarly, if you factorize 15, you will get exactly 1 5. So that's where it is 1, but you don't get any 0. That's where it is 0. Now for let's take another example. For 40 you will get like 40, if you factorize 40 you will get three twos, basically 8 has three twos and one 5. So that's why this is 3 and this is 1. So hope you got the intuition here, like how we have built this matrix. So basically we have just factorized each element and put number of twos here and number of fives there. So now once we have these two, what we will do, as discussed, for each cell, let's say we are currently at set r comma c. So for each cell we will do this thing. So let's say this is r comma c. So for we will do this, we will calculate this, right? So let's say r comma c is this one. Okay, or let me change the color. So r comma c is, let's say, this one. So for this you will do calculate the sum here and there. So sum here is, like, this is the path and here this is the path. So how many fives are there? There is no fives, right? And there are four twos, 1 plus 1 plus 2. So there are four twos but there are no fives. So minimum of 0 and 4 is 0. So for this path, number of trailing zeros will be 0. Now let's similarly let's consider the next path. So next combination is this, right? So let's take this as well. So this and this. So if you see, number of fives is again 0. There is no 5 at all. So that's where number of twos is again like 2 plus 1 plus 2 5. There are 5 twos but there are no fives. So minimum of those two is 0. Basically we can't make 10 because we want exactly 1 2 and exactly 1 5 to make 10, and there's no 5 at all. So basically we can't make, so the number of trailing zeros for this path is also 0. uh, Now let's take the third possible combination, which is this path. So if you take this path, number of fives here is 1 plus 1, which is 2, and number of twos here is 2 plus 1 plus 1, which is 4. So minimum of 4 and 2 is 2. Basically, we can make two trailing zeros. If you multiply everything here, we will get two trailing zeros. So if you can try multiplying everything here, and you will see there are exactly two trailing zeros, because in the factorization of the product, we will have two fives and we will have four fours, and one 5 and one 2 will combine to make one trailing zero. So 2 5 will combine will two with 2 2 to get two trailing zeros. So in this path we will have two trailing zeros. So remember, in the first one we get 0, second one we get 0, and in third one we are getting 2. So maximum is 2 till now. Okay, so now let's take the last path, which is this one. Okay, so if you take this one, so uh, number of twos is 5. Number of fives are 2. 1 plus 1 2. So minimum is again 2, because so we can make two trailing zeros in this path. So maximum of all the four path is 2. We get 0 from the first, 0 from the second, 2 from the second, third, and 2 from the fourth. So maximum of everything will be 4. So for this cell, for this cell, if we traverse all possible paths, we will get at max 2 trailing 0. So we will continue this process for all the cells in this grid and take the maximum across all the things. So hope the approach is clear. Now one thing, we are we are calculating the sum across this thing, right? We have to calculate the sum across this thing, this entire thing. So if we try to calculate the sum in the naive may brute force manner, we will be requiring r plus c time, right? So we already have r into c into 4, sorry, so we already have r cross c into 4 in our time complexity, but we can't afford another r plus c here, right? So that is not so. To speed up this entire thing, we can use prefix sum. So we can try to find the prefix sum of this row, and we can try to find the prefix sum of every column. So basically we will try to find prefix sums of every columns here, and we will also try to find the prefix sum of every row here, and from that we will get the exact value that we want. So let's say you have already have the prefix sum of every row. So for this particular path, how will you get the total sum of 5? Basically prefix sum until prefix sum for this row at this position minus prefix sum of this row at this position, which is 0. So basically prefix sum of this row at this position. Now similarly, if you have prefix sum of, let's say, column, you have prefix sum of this column, how will you find the value of this? It is simple, just get the prefix sum of this column at this row and subtract the prefix sum of this column at this row. So you will get the exact prefix sum. You will get the exact sum, exact number of fives in this path. Similarly, you can find the exact number of twos in this path. So hope the approach is clear. Let's just look at the complete solution once. So what we are doing is we are calculating the prefix sums of twos and fives, and for each row and each column we are calculating up 5, up 2 and up 5. Basically up 2 denotes number of twos in the upward direction. So let's say this is r, this is r comma c. So number of twos and number of fives in this direction is up 2 and up 5. Similarly, we calculate down 2 and down 5, number of fives and number of twos in this particular direction. Similarly, we find left to left 5 and left right to right 5. So number of 2s and number of 5s in these two directions. And then we combine all the pairs. So these are the 4 pairs possible. We combine all the pairs and take the max one. So this is for a single row and single column. We will do this for every row and every column, and we will get the answer. So hope the entire approach is clear. Let's look at the code for this. So this is the code. Notice the time, like forget about the time complexity of this. Time complexity of the solution is r cross c cross 4. But forget about the test cases here. Test cases here are like pretty strong, or unnecessary tight bounds are there for this problem. But eventually our time complexity is r cross c cross 4 with some constant factor. So what we have done is, as discussed, we will calculate the prefix sums. So ph5 denotes the prefix sum of horizontal. Horizontal means the row wise, right? Prefix sum of horizontal of 5, prefix sum of horizontal of 2, prefix sum of vertical of 5, prefix sum of vertical of 2. So for each row and each column, we calculate exact number of twos and exact number of fives in that particular cell. Basically, number of twos and number of fives is we can just find by doing this. Like just keep on dividing the current number with this particular number until this number is there in the actual number. So this is the simple logic to find the number of factors. So we will find the number of twos and number of fives in current cell, and then, as discussed, we'll calculate the prefix sum horizontally and vertically, right? So for horizontally, basically we have to calculate the prefix sum horizontally and vertically, right? So the value of prefix sum vertically here will be the value here plus whatever number of twos are here. So that's what we are doing. The value of prefix sum vertically is value in one row above plus current. Similarly, for two, one row above plus current. And for horizontally, value of prefix sum of this will be value of prefix sum of this plus this current row. So that's where we are doing value of prefix sum of one row less and current number. So from this we get the prefix sums. Now once we have prefix sums, The rest of the things is exactly what we have discussed. So for each row and each column, we will try to find up to and up 5. Basically, up to and up 5 denotes the number of twos and number of fives in the upward direction. So this will be directly equals to the prefix sum. So prefix sum basically denotes number of twos and number of fives until this, right? So that's where this is the exact prefix sum that we want for vertical case. For down, we will just subtract this from the last, the value of the last. So we have the last contains the prefix sum of entire thing, and this contains the prefix sum of until there. So if we subtract this, we will get the prefix sum until of this part. So that's what down 2 and down 5 denotes. Similarly, left 2 and left 5 denotes the horizontal part. We have just taken the horizontal part, and then we have made just to ease. Remember, we have to make these four pairs, right? So just to ease making this pair, what I am doing is I am just appending it in a vector and iterating over every possible combinations of this horizontal and vertical. So number of fives will be number of fives here plus number of fives here and current five. So basically this up to and up 5 doesn't have the number of fives in the current row. So notice that this is r minus 1. So we are calculating up till, so for this row, let's say, let's take an example. So for this row, up to denotes the value of this part, down to denotes the value of this part, right to denotes the value of this part, and left to denotes the value of this part. So if you want this entire path, the value of this entire path, you have to sum this current node as well. So that's what we are doing. Number of fives in horizontal and vertical plus current 5, similar number of fives in number of twos in horizontal and vertical, and then plus current number, and finally we take answer as max of answer comma current, the value, what will be the value of number of zeros in current case, it will be min of 5 and 2. So that's what we have done. So hope this entire approach is clear. If you have any doubts in this problem, please post them in the comment section below, I will answer them. And I am regularly uploading the videos of such kind, and also several follow-ups of different interview experiences of Leetcode. So do subscribe to the channel and stay tuned for future videos. I will see you tomorrow. Thank you.